Hey everyone, welcome to another BTM screencast. Today we're going over Chapter 2, Hardware and Materials Used in Residential Wiring. Some of the objectives are to list several nationally recognized testing laboratories and demonstrate an understanding of their purpose. Identify common box and enclosure types used in residential wiring. Identify common box covers and raised rings used in residential wiring. Identify common conductor and cable types used in residential wiring. Identify types of cable connectors, conductor terminals, and lugs. Identify common raceway types used in residential wiring. Some other objectives are identify common devices used in residential wiring, identify common types of fuses and circuit breakers used in residential wiring, describe the operation of a fuse and a circuit breaker, identify common panel boards, load centers, and safety switches used in residential wiring. Identify common types of fasteners, fittings, and supports used in residential wiring. First, we'll go over what the nationally recognized test laboratories are. So to understand what those are, we have to look at the National Electric Code, which states that the authority having jurisdiction, or AHJ, approves electrical materials used in an electrical system. Many authorities having jurisdictions base their approval of electrical equipment on whether it is listed and labeled by an NRTL. NRTL evaluate products to see if they meet a series of designated standards, and if the products do, they are placed on their list and labeled. Three primary NRTLs that you'll see are the Underwriters Laboratory, or UL. You'll see this on a lot of appliances. CSA International, once known as the Canadian Standards Association. They test, evaluate, and list electrical equipment. Intertech Testing Services, formerly known as Electrical Testing Laboratories. Underwriters Laboratory, most manufacturers of electrical products submit their products to UL. Again, you'll see this label on a lot of electrical products if you look for it. Once UL determines that the product complies with the specific standards for which it is tested, the manufacturer is allowed to put the UL label on the product. UL directories, they're for residential wiring. There are 3 UL directories electricians should consult. The Electrical Construction Equipment Directory, or the Green Book, the Electrical Appliance and Utilization Equipment Directory, or Orange Book, and General Information for Electrical Equipment Directory, or the White Book. Electrical boxes, some are metal device boxes used to install receptacles or switches at specific locations on an electrical circuit. Standard box opening is 3 inches by 2 inches with a depth that ranges from 1.5 inches to 3.5 inches. Most common metal device box sizes are 3 inch by 2 inch by 3.5 inch. And here's some more metal device boxes. A metal device box has many features, including the capability of having the sides of the box removed, and the boxes gang together to make a box that can accommodate more than one device. So if you look right here, you can see that these two were ganged together. And this is what they're referring to when they're ganged together. So this was just a single gang box, and now it's a double gang box. Another type of metal device box is the handy or utility box. This is primarily used for surface mounting and can accommodate one device such as a receptacle or switch. So we will be using these in class. They're simple to use. They're pretty useful. We'll be mounting our switches and duplex receptacles in there. We'll also be using these in lab. These are non-metallic device boxes. They're usually made of PVC, phenolic, or polycarbonate. They're lightweight, strong, very easy to install, and inexpensive. You can see that these go in. There's little ears right here that you'll see when you're in lab, and these go right up against the stud. So your stud would lay here, and the reason that you stop where these ears are for when the drywall is installed, that this isn't recessed in your drywall. And there's just 2 nails, that go right in, and that's it. They're used with non-metallic sheath cable or Romex, which we will be using. They're available in single gang, 3-gang, and 2-gang styles. So here we have the single gang, 2-gang, and of course the 3-gang style. Outlet boxes, these are some other ones. They're used when installing lighting fixtures in the ceiling or on a wall. We will be using these to install lights. They're used when connecting small or large appliances. They're a little bit larger than a device box, and it provides more room for different wiring situations. And you can see the ones they have here. They're round, octagon, or square shape. So it depends on the application. Here we have some other outlet boxes. So this one, what we were talking about before, with the little lip that you leave on there, this is used as raised plastering. So that way your drywall can finish flush with the box that you're using. And these would be when you're going to surface mount them. Junction boxes. So they're used when several conductors are spliced together at a point on the wiring system. The NEC requires junction boxes to be accessible after installation without the finish of a building having to be altered. So this is an important point. And they must always be covered. These are the covers that you'd be using. And here's some special boxes for heavy loads. They could be used for ceiling fans, and you'll see that it's a specific ceiling fan box, such as this one. They can be made of metal or non-metal, and they're specifically designed and tested to support heavier loads. In other words, you can't use boxes that are used for a light fixture to support a fan. You'll usually see that there's a rating on the box for the amount of weight that it can take. Conductors in residential wiring are usually installed in the cable assembly. They're made of copper, aluminum, or copper-clad aluminum. Copper is preferred because of its great ability to conduct electricity, its strength, and its low instance of problems over the long term. Conductor sizing. Conductors are sized according to specified diameters and cross sections by the American Wire Gauge, that's AWG. Conductors used in residential wiring typically range in size from 14 AWG to double-aught copper. The larger the number, the smaller the conductor. The smaller the number, the larger the conductor. So if we go by the example that we have here, where we have a 14, and this would be a double-aught, or this number, because it's a higher number, would be a smaller wire gauge. This number, because it's a smaller number, would be a larger wire gauge. Conductor size is larger, then that'd be a quad-aught, 4-aught, or listed in KCMIL. KCMIL stands for 1000 circular mils. Example is 250 kc mil, 500 kc mil, and 2000 kc mil. Conductor ampacity. Ampacity is the current in amperes that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. A residential electrician must be able to choose the correct conductor size based on the ampacity needed for each circuit they are installing. The ampacity of a conductor depends not only on the size of the conductor, but also on what insulation type the conductor has. Conductor color coding. The NEC requires that each conductor be color-coded to indicate the function that it performs in a circuit. Black is used as an ungrounded or hot conductor and carries the current to load in 120-volt circuits. Red, also used as an ungrounded or hot conductor and carries current to the load in 120 or 240-volt circuits, like an electric clothes dryer circuit. White is used as the grounded circuit conductor returns current from the load back to the source, often called a neutral conductor, but only truly neutral when used with black and red wire in a multi-wire circuit. Bare, used as equipment grounding conductor that bonds all non-current carrying metal parts of a circuit together. Does not carry current except in a ground fault situation. Green is used as an insulated equipment grounding conductor, could be green with one or more yellow stripes. Conductor connections. In residential wiring, the most common type of wire connector used to splice two or more conductors together is called a wire nut. And here we have some examples of different wire nuts. And we'll be using those in lab. Cable types. Non-metallic sheath cable, type NM, also known as Romex, is the least expensive wiring method to purchase and install. Most common wiring method used in house wiring. There are three types of type NM cable. Type NMB, the most common, used in dry locations only, has flame retardant, moisture resistant, non-metallic outer jacket. Type NMCB, not used as often in residential work, used in dry or damp locations, has flame retardant, fungus and corrosion resistant, non-metallic outer jacket. Type NMSB, used in new homes with automation systems, contains power conductors, telephone wires, coaxial cable for video, and other data conductors all on the same cable. Has moisture resistant, flame retardant, non-metallic outer jacket. Another cable type is the underground feeder cable, or type UF, used for underground installation of branch circuits and feeder circuits. Also can be used in interior installations, but must be installed following the installation requirements for non-metallic sheath cable, type NM. Another type of cable that we'll be using in class is armor-clad, or type AC, and metal-clad, type MC cable. Certain locations in the US may not allow non-metallic sheath cable, or type NM, in residential construction. Both have a metal outer sheathing and provide very high levels of physical protection for the conductors in the cable. Electricians sometimes find it hard to tell type AC, also known as BX, and type MC apart. Type AC cable has paper covering each conductor, which you can see in the top right here. And type MC has a clear plastic wrap around all the conductors, which you can see here. Another type of cable is service entrance cable, type SE and USE. Supplies electrical power from the utility company to a building's electrical system. Can also be used to supply a large appliance like an electric range. This U is for underground, so we have our service entrance and underground service entrance. There are three types of service entrance cable. SEU cable is used for service entrance installations. SER cable is similar to SEU. It has four conductors wrapped in a round configuration, used as a feeder from a service entrance equipment to a sub-panel. USC cable is used for underground service entrance installations. Cable fittings and supports. Connectors are used to connect the cable to an electrical box. And here you can see that there. It's a Romex connector. And here we have other connectors. Cables are supported by a variety of items, including staples, stackers, and cable straps. And here we have all of them lined up for you. Staples are most common to secure and support cables and residential wiring. Raceways are defined as enclosed channels of metal or non-metallic material designed expressly for holding wires or cables. Raceways used in residential wiring include rigid metal conduit, or RMC, and intermediate metal conduit, or IMC. Some other examples, so we have electrical metallic tubing, or EMT, rigid polyvinyl chloride, or PVC conduit, and flexible metal conduit, or FMC. More raceways. So we have electrical nonmetallic tubing, ENT, liquid tight flexible metal conduit, LFMC, or liquid tight flexible nonmetallic conduit, LFNC. Devices. A device is defined as a unit of an electrical system intended to carry, but not use, electrical energy. Devices include switches. We'll be using single pole and double pole switches, as well as three-way and four-way switches, receptacles, attachment plugs, and lamp holders. First, we'll go over receptacles. It's a contact device installed at the outlet for the connection of an attachment plug. So here we have a single receptacle. Here we have a duplex receptacle. And here we have two duplex receptacles. While many people refer to a receptacle as an outlet or a plug, it's the wrong term to use. It's a receptacle. The duplex receptacle is the most common type of receptacle used in residential wiring and rated for 15 amps at 125 volts. So here you'll see it's rated for 15 amps and this one for 125 volts. This is the most common that you'll see in your house. You might see a 20 amp. You can check here and it'll also have an additional slit. It consists of two receptacles on the same mounting strap. The silver screw terminates the white grounded conductor, which is over here, and the brass screw terminates the hot conductor, which is here. When you put your loops on, always make sure they are done clockwise. Tamper resistant receptacles, almost all 15 or 20 amp 125 volt receptacles are tamper resistant. So the slots are closed until a plug is inserted. This way, you need to put the plug in for these to open up. Ground fault circuit interrupters, or GFCI receptacles. They're used to protect people from electrical shock. Ground faults are when a hot conductor and ground accidentally connect. The reset and test buttons in front of the GFCI are used for regular testing and resetting it. So you'll see your reset and then your test button. Incoming power is connected to the line terminals, which you can see in the back, right there and right there. Another device is an arc fault circuit interrupter, or AFCI receptacle. AFCI receptacles are intended to protect homes from the effects of arc faults. AFCIs are designed to detect a wide range of arc faults to help reduce the likelihood of electrical system being an ignition source of a fire. Some special receptacle types. They're larger with different configuration than a single or duplex. Two appliances typically require a special receptacle or an electric range and an electric clothes dryer. And here you'll see the plugs for both of those. Switches are used to control various lighting outlets installed in residential wiring. The single pole switch used in 120 volt circuits to control a lighting outlet or outlets from only one location is the most common. And we'll be wiring these in class. One thing you'll see with the single pole is that they have an on-off. The double pole switch is used for 240 volt circuits to control a load from one location. For example, an electric water heater. And like the single pole, the double pole will also have an on-off. Your three-way and four-way switches will not have that designation. Three-way switches are used in 120 volt circuits to control a lighting load from two locations. So if you have one of these by your front door, you might have another one in your kitchen to control the kitchen lights. And that's so you can use it from two different locations. Or you might have one at the bottom of your stairs and then at the top of your stairs so you can control the light from two different locations. 4-way switches are used in 120-volt circuits to control lighting load from 3 or more locations. They are used with 2 3-way switches. We'll go over this more in lab as for the applications and how they are wired. Dimmer switches are used to brighten or dim lighting fixtures' lamps. Some of them you'll see are the rotating knob ones, and the other ones are the sliding knob ones. Some other switches are combination devices that have a combination of 2 devices, both of which are mounted to the same strap when more than one device is needed at one location. There could be 2 single pole switches, a single pole switch and a 3-way switch, or a single pole switch with a pilot light. So here you can see that these would be 2 switches. Overcurrent protection devices. In residential wiring, overcurrent protection devices consist of fuses or circuit breakers. The NEC states that overcurrent protection for conductors and equipment is provided to open the circuit if the current reaches a value that will cause an excessive or dangerous temperature in conductors or conductor insulation. Some common overcurrent protection devices are a circuit breaker. They're an automatic overcurrent device that trips into an open position and stops the current flow in an electrical circuit. A single pole breaker on the left and a 2-pole breaker on the right. So this would be for your 125 and this would be for your 240. Another overcurrent protection device is a fuse. It opens the circuit when the fusible link is melted away by the extreme heat caused by an overcurrent. You may encounter 2 different styles of fuses. One is a plug fuse, such as this, and the other is a cartridge fuse. Panel boards and load centers. A panel board is a single panel that includes automatic or overcurrent devices used for the protection of light, heat, and power circuits. A load center is a type of panel board that contains the main disconnecting means for the residential service entrance, as well as the fuses or circuit breakers used to protect circuits and equipment like water heaters, ranges, dryers, and lighting. Safety switches, we have several of these around the lab. It's used as a disconnecting means for larger electrical equipment. It's typically mounted on the surface and is operated with an external handle. Some of these fasteners you should be familiar with. Just going to go over these real quick. There's nails there. Different types of anchors are used to mount electrical equipment on surfaces like sheetrock or masonry. Some examples are toggle bolts, which we have here, wallboard screws or drywall screws, which you should be familiar with, mollies, lead anchors, and tapcons. Here we have tapcons. This is a plastic drywall anchor. Screws are used to secure electrical equipment to a variety of materials. For examples, wood screws, sheet metal screws, sheetrock screw, and self-tapping screw. So here we have some self-tappers. Here we have wood, sheet metal screws, drywall screws. Nuts and washers are used with thread fasteners in many applications to help secure an electrical item in place. Cable ties, sometimes called tie wraps, are often used to fasten a bundle of wire or cable together. That's it, and we'll see you next time.